Hi students, welcome to my lectures on chemical reaction engineering. In today's lecture, we are going to learn how to find order of a reaction. That means rate of a reaction, that means speed of a reaction could be 0 order, first order, second order, it could be any order. Okay. And how people will come to conclusion it is a 0 order reaction or first order or second order. Because it is important to find the orders to design the reactors, because every order have a different speeds. Okay. If you do not know what speed the reaction is happening, you cannot design a reactor. So, in the today's lecture, we are concentrating on finding the order of a reaction using differential method of analysis. Of course, there are other methods to find the orders like integral methods, differential methods, half-life methods, Ostwald isolation methods. There are a number of methods are existing, but today I am concentrating on the differential method of finding the order of a reaction, because we can compare with the real life experiments, real life things that is going on in your life if you apply the differential method of analysis. And this is how I am explaining a situation like a person is trying to is in a marathon, he has to cover the 20 kilometers to finish the race. He has started with the 20 kilometer and come to 0 kilometer, that means 20, 19, 18, 17, 16, like that he has to cover the entire distance. Okay. And based on what speeds he is covering the distance, okay, we can find out whether it comes under the 0 order or first order, second order or any order. We can draw some analogy from it. That is, a person is covering a distance from 20 kilometer to 0 kilometer with a certain time frame. Similarly, if we are conducting a reaction, we have started with 20 moles per liter in the reactor, and during the reaction the concentration will reduce and finally it reaches to 0. Okay. We will compare with both the situation so that it is easy for anyone to understand. Let us go with the proof. I mean, what exactly you are trying to prove today is the 0 order reaction. 0 order reaction is nothing but minus Ra, the rate of a reaction is equal to minus dCA by dt, which is equal to K. K nothing but K times Ca power 0, anything power 0 is 1, and if you count the order of the reaction, that means if you remember my earlier lectures that if you summate all the powers of concentrations, then you get an order. Here Ca power 0, there is only 0 order reaction. That means Ca power 0 is nothing but, that means dCA by dt is nothing but K, minus dCA by dt is equal to K. So, this is we have to prove that it is a 0 order reaction. I mean, dCA by dt is rate, means speed, right. In 0 order reaction, dCA by dt is equal to K, that is constant, that means speed of the reaction is constant from the beginning to the end. That is what the 0 order reaction, irrespective of whether it is a 20 mole per liter, the speed is the same, whether the react and whether the concentration is 50 mole per liter, still the speed is the same. If the speed is the same irrespective of the concentrations, then it is called 0 order reaction. Let us try to prove today. I have plotted analogy, that marathon analogy. On the y axis it is a distance, on x axis it is the time. The distance is in the kilometers and the time is in minutes. The person should cover from 20 kilometer to 0 kilometer from time, I mean this much, okay, 120 minutes. Okay, the person will first 20 to 15 kilometers, the person has taken 0 to 30, that means 30 minutes. Second, 15 to 10 kilometers, the person has taken 30 to 60 minutes. From 10 to 5 kilometers, the person has taken 60 to 90 minutes. And 5 to 0 kilometers, the person has taken from 90 to 120. That means every 5 kilometers, he has taken 30 minutes. That means let us calculate the speed. Speed is nothing but dd by dt, slope of this line. Between 20 to 15 kilometers, my dd by dt, the slope of this equation is minus 0.16, because negative is the slope, because the line is in, I mean the slope is negative. Okay, do not worry about the slopes positive or negative. The speed is 0.16 kilometer per minute. Okay, between 15 to 10 kilometers, what is the speed dd by dt at between the second step, 10 minus 15 by 60 minus 30, it is again 0.16. That means the speed between 20 to 15 and the speed between 15 to 10, it is the same. The person has covered the distance with the same speed. Between 10 to 5, again if I take the slope dd by dt at 3, again it is 0.16. See, again 5 to 0, again the slope is 0.16. That is, every time the person has covered the distance with the same speed, irrespective whether it is 10 kilometers, whether he is in 5 kilometers, whether he is in 15 kilometers, he covers the distance with the same speed. This is called the zero order. Okay, that means now you draw the analogy today. Replace this distance with the term the concentration, okay, in moles per liter. Okay. Now I have started a reaction in a batch reactor. The initial moles I have kept is 20 mole per liter. Okay. I have started the reaction first for the reactant A concentration 20 to reach to from 20 to 15, the reaction has taken 30 minutes. To reach the concentration of A from 15 to 10, and again he has taken 30 minutes. 10 to 15, again the reaction has taken 30 minutes. Again from 5 to 0 mole per liter, and it has taken the again 30 minutes. That means whether it is 20 mole per liter or 15 mole per liter or 10 mole per liter, it has taken same time. That means the speed of the reaction, the rate of the reaction is same whichever may be the concentration is. So when you slope is same everywhere, that means the speed is the same. If the speed is same, that is speed is constant. When speed is constant, that means dCA by dt is equal to constant. This is called zero order reaction. Okay, that is why the velocity dCA dd by dt1, dd by dt2, dd by dt3, everywhere the speed is 0.16. So this is, you can apply this analogy, that the zero order reaction. Then in general, once you get the slope data, how people will come up with the equation like dCA by dt is equal to k. Okay, let us take example. dd by, you have to plot the concentration dCA by dt and the concentration. dCA by dt on y axis, the concentration is on x axis. What is dCA by dt? The dCA by dt 1.16. The slope at this average concentration, what is average concentration? 20 plus 15 by 2. At this average concentration, what is my speed is 0.16. Again at this 15 plus 10 by 2 average concentration, what is my speed? Again 0.16. At between 10 and 5, the average is, average concentration, the speed is 0.16. Between 5 to 0, the concentration, is 0 plus 5 by 2 average concentration, the speed is again the same. Now you have got the data. Plot minus dCA by dt on y axis, the average concentrations on x axis. Now you fit the line, and you can observe whichever may be the concentration, the speed is the same. It is not rising, it is neither dropping. If that is the case, it is called zero order reaction. Now fit this line. If you tell this line, it is nothing but the order of the reaction. You can find out the order of the reaction. Any line parallel to x axis, nothing but y equal to constant. What is y in our case? Minus dCA by dt. Minus dCA by dt is equal to k. What is this k? 0.16. That means 0.16 into Ca power 0. That means you have found out that minus dCA by dt is equal to k. That means typically you see this kind of equation for a zero order reaction. Zero order reaction means there is no relationship with the concentration. If there is a relationship with the concentration, you would have got a Ca power 1 or Ca power 2. Okay, you didn't get this relationship. Straight away you got Ca power 0. That means it's a zero order reaction. Hope you understood the beauty of the differential analysis. So let us meet with the new lecture. Thank you.